every one of you. കാണാവോ നിങ്ങൾക്ക് എല്ലാവർക്കും properly?
Yes, sir.
Okay. So today, this is your module 1, probably. Just a second. So today you have your module 1, that is structural elucidation using spectral data. Okay, this is a very important part in particularly in organic chemistry as well as in other types of chemistry also. Spectroscopy play a very important role. So that's why this particular quotation I have used here, it's like structural elucidation is the soul of organic chemistry. Why I'm saying that it is a soul of organic chemistry is that because right now when you study organic chemistry, you know exactly the structure of the compounds because it is written very clearly. Okay, what is the structure of the compound, so you know it. Okay, but when you actually do any preparation in your lab, which you so far haven't done, probably in the coming practicals, you'll be doing some simple um, uh, preparations, okay, of certain organic compounds. So when you do any kind of preparation, not just organic compound, even inorganic complexes also, you might be preparing some tetraamine complexes in your classes. Okay, so be it any kind of molecule or compound that you make in the lab, by looking at that sample, usually when you synthesize, it would be like a solid, or it might be like liquid or a crystal. By looking at it, you can never know the exact structure of the compound. Okay, so how to know the structure is a very important job in chemistry. Okay, by looking, we cannot say, okay, this is benzene or this is any other, so far any other compound. Okay, you cannot by look determine the structure of the compound. So we require certain strategies in order to know the structure. Particularly, this is useful, as you can see here, I have written in medicinal chemistry. Unless we know the molecular structure, we cannot advance the medicinal chemistry. Why? Because suppose if some natural product is there, okay, and using that natural product, we know that it is able to cure a certain kind of ailments in our body. Okay, but without knowing what is that compound that is actually curing that ailment, okay, we will never able to advance into more better molecules for treating a particular sickness. Okay, so that is why the understanding of the molecular structure is pretty important, and that there actually this structural elucidation is very, very important, because when you know the structure of a molecule, you can then advance into newer medicines with modified molecular substitutions to develop a more better drug for any kind of sickness in the body. So that is what is important in important when I say that structural elucidation is the soul of the organic chemistry. Now, this spectroscopic techniques, okay, which I'll be telling you, which are all the spectroscopic techniques that are used. Before the advent of the spectroscopic technique, there were methodology, various tedious, strenuous methods that were used to find the structure of the molecule. So if we look at the primitive method, how in older days scientists used to determine the structure of the molecule, if we try to understand that, we see that it composed of 3 steps. It basically composed of 3 steps. The first step of determining the structure involves determination of the molecular formula. And this determination of molecular formula was usually done using elemental analysis. Okay, so you might be aware of elemental analysis. Sometimes you might have solved in your 11th and 12th, like you were given when you burn the compound, you get certain percentage of carbon, certain percentage of hydrogen, oxygen, nitrogen, and then using those percentages, you calculate the empirical formula. Okay, and from that you ultimately get to a proper molecular formula. So that is called elemental analysis. You might have done definitely in your 11th standard. I remember I did some problem solving of elemental analysis. So basically that involves combustion of any compound and determining how much percentage of each atom is present in the molecule. And from that, we first calculate the empirical formula, and then we come to a proper conclusion of the molecular formula. So that is how we did determine the molecular formula in the older times. Okay. Second stage after the determination of molecular formula is determination of the physical properties. Physical properties like those which we can uh, determine using the physical parameters. So something like melting point, boiling point, density. Okay, all those are physical properties we determine for a particular compound, because every time any compound is discovered or the structure is known, they always study these physical parameters. So when you deal with an unknown compound, it is always mandatory that you look for these physical parameters so that you can compare with the literature values to see whether the compound that you have in your hand is the same compound or is it a different compound. So determination of physical and boiling point is a very important part of the structural elucidation. Third stage involves simple chemical test. Okay, simple chemical test means basically you do certain known chemical reactions in order to determine what type of functional group is present in your given sample. Okay, so that is how we come to know a general idea about the structure of the compound. So we do all the permutations and combinations to ultimately get to a most probable structure. Okay, that too is we are not sure. Often when a new person comes up with a certain idea, the older structure that was proposed might get wrong. Okay, so that was a very much a drawback when people used to use this primitive methods to determine the molecular formula, okay, or the structure of the compound. Now, these particular thing, like simple test to determine the functional group, the physical properties like melting point, this thing you will be doing in the qualitative analysis of organic compounds in your practical classes. Okay, there you will be doing certain chemical tests to determine what kind of functional group, like whether it is a carbonyl compound or whether it's an aldehyde or it's an acid or it is a nitro compound, okay, or it's a primary amine. അങ്ങനെ പല ടെസ്റ്റുകളുണ്ട്. അത് വെച്ച് നിങ്ങൾ you will try to determine what type of functional groups are present in your molecule. And then what you do is you determine these physical parameters, and then every organic textbook has on the back of it the list of melting and boiling points. So you check where exactly this particular compound falls, and you get to know what exactly is your compound. Okay, since we are giving you known compounds, so you easily compare with the literature values to find out which compound exactly is the one that we have given to you. Okay, so this particular primitive thing you would be doing in your lab. Why we always make it a point, even though it's a very primitive methodology of determination of structure of a compound, why we still follow in the lab, you might ask. Okay, the reason why we are doing this is because this particular doing of this analysis and these tests, though it has become obsolete and we don't use it now, but still it would give you a kind of experience into the experimental techniques that we use to do any kind of reactions. Okay, so that is why the syllabus of the universities. Any university you go, they haven't removed this particular thing, because this gives you a very good experience into how to do the practical experiments in a lab. Okay, so that is why you will find these things always there in your, even in your MSc class also, when you go for your post graduation also, you will have these experiments, because this will train you up for doing various analysis. Okay, and here I have written down that this particular way of determining the structure really failed, because when it comes to complex structures, so if you have compounds which are very complex, very big, with lot of substitutions present, then using this technique, it was very difficult to determine the structure of the compound. Okay, and often these kind of structure elucidation required very large amount of sample. Okay, so if you have compound which are like available in very minute amount, okay, so those you cannot determine using this particular primitive method, because you always require very large amount of compound to actually determine the structure using these techniques. Okay, so that is why we needed a more advanced way of determining the structure of the compound. So later, in the early part of the 20th century, we discovered certain techniques to determine the structure of the compound. So now, in the current scenario, if you have any unknown compound available, using these various techniques, you can easily determine correctly, without doing a single experiment, you can determine the structure of that compound. That is the power of the spectroscopy that you have in your hand. Okay, so once you understand this particular technique, okay, wherever you go, when you involve in your research, when you develop some new compounds, okay, then when you use these spectroscopic techniques to just measure out the spectrum of these unknown sample that you have prepared, you can very quickly determine what exactly is the structure of the compound. Okay, so that is why this particular technique, though initially you might feel looking a little bit complicated, like, but it isn't a complicated topic. Okay, once you understand, once you are familiar with the functional groups and how these techniques work, then it would be pretty easy for you. Okay, so let me introduce to you various techniques that are usually used in organic chemistry to determine the molecular structure. One of the techniques that we use is mass spectrometry. This mass spectroscopy we do not have in your, you do not have in your syllabus. Okay, this you will be dealing more in detail when you go to your PG level. Okay, there you will talk more about the spectrometer. But if you have a curiosity to read about it, the textbooks that I'm uploading in there, okay, particularly Organic Chemistry by Paula L. Bruce, it's more simpler to understand, okay, because Pavia is a more advanced book. If you can just read through the mass spectroscopy, you might get a fair idea about what it is, okay. So you can, those who have interest to just go through it, just read those portions from those books. It's good for you to know it, because it gives always, if you have a pretty much better knowledge of it, you would be like on a very higher end, okay, of your competitors. Okay, so always try to have little bit extra knowledge and extra understanding of anything, because it will help you further in your journey. So often when we used to study, we never studied exactly according to syllabus. So we always moved little extra. We used to study a little extra. We will go to look for certain books and read more about those topics. That's how you develop the understanding of a particular topic. If you just stick on to your syllabus and just wait for the way you get the marks, that will never increase your knowledge, and you won't be having that cutting edge over the competitions that you're going to face ahead in your life. So always remember, if you want to stay in the competitions and be on the plus side, you have to give a little bit extra to what you are doing right now. Okay, so always keep that in mind, and with that aim, you should always move ahead. Okay, so mass spectrometry. So what is the use of mass spectrometry? So mass spectrometry is basically by using this particular technique, you can easily find out the molecular weight or molecular mass, exactly to be said, or and also the molecular formula. Once you get the molecular mass, you can easily find out the molecular formula. There are certain techniques that we use to determine the molecular formula, and also using this technique we can get to understand the a feeble idea, not the whole structure, but you get some structural idea from this mass spectrometry about the structural framework that might be present in a particular organic compound. Okay, so mass spectrometry, as the name suggests, it will give you the correct molecular weight of the compound, and from the molecular weight you can easily determine the molecular formula. You can get to a more perfect molecular formula, and also you can get some indication about the structural features of the compound. Okay, then another important technique in spectroscopy is the infrared spectroscopy. Okay, here this particular technique is basically used to determine the kind of functional groups present in an organic compound. So as I told you, in primitive methods, we used a chemical test to find out whether what kind of functional group is present in your organic compound. So here, infrared spectroscopy is such powerful that you do not have to do any single experiment. Just if you have a sample, you can load that sample in your spectroscopic instrument. We have in our college this infrared spectroscopy. Okay, so might be if you do some projects, but you do not have experimental projects this time. But we used to use infrared spectroscopy to determine the spectrum of the compound. So this powerful technique would give you an indication about the functional group that are present in the molecule. So if your compound contains carbonyl compound, or if your compound contains hydroxy groups, okay, or if your compound contains certain groups like cyano, okay, you can easily, from the spectrum that you get in this infrared spectroscopy, you can easily find out the nature of your functional group. Okay, so infrared spectroscopy is the one that gives you an indication about the functional group of the organic compound. Now, another important technique is the ultraviolet or visible spectroscopy. Okay, ultraviolet or visible spectroscopy. This particular technique is particularly useful when you have conjugated double bonds present in your molecule. So aromatic compounds, okay, because aromatic compounds contain conjugated double bonds, or compounds like diene with the double bonds conjugated to each other. So such type of molecules, if you have present, this particular technique will give you a good understanding about the features of these conjugated double bonds. Okay, so that is why this particular technique is particularly useful if you have conjugation present in the molecule. Now, how this is useful to determine the structure, or what are the informations that it gives, we will understand better when we go into the details of it later on during the study of this particular module. Okay. Now, another very powerful technique in organic chemistry, I must say that the king of all these spectroscopy is this particular nuclear magnetic resonance, that is NMR spectroscopy. This is the most powerful technique you have to determine the structure of the organic compound. This particular spectroscopy, though in your course we have only one-dimensional spectroscopy, so that is only we are going to concentrate on, but you can do a lot of experiment, like there is 2D and 3D NMR spectroscopy, with which you can determine the exact structure and confirm that structure using this particular technique. Okay, so this is a very powerful tool that will give a good indication about the carbon-carbon bonds and CH bonds and how they are connected. All those features are very well given by this particular powerful technique called nuclear magnetic resonance spectroscopy. Okay, so I hope while we are going into the details of this particular spectroscopy, you will enjoy these things. So please be attentive. I'll try to usually upload the videos before the class so that you can go through it. So that in the class, in the lectures time, we will just have a normal discussion about these topics. Okay. So we will not do any class during the class hour. We will just use it for interactive session discussing whatever has been told. So usually I'm going to upload the videos before the class, so go through them and try to learn from that. Okay, so moving further, now here I would like to understand like what you know about it. So see, here you have you know that there is something called spectrometry used here, and in other techniques you see the word spectroscopy being used. So since you have already done, I guess, the molecular spectroscopy, can you tell me what you remember about this particular term called spectroscopy? What do you know about spectroscopy? Can any one of you just enlighten us on your understanding about this term called spectroscopy? So let me call your name. Let me call Gayatri. Okay. So Gayatri, are you present today?
Yes, sir.
Okay. So what do you know about the word called spectroscopy?
Um, Sir, study of
Mhm.
different spectra when radiation interacts with matter,
Mm,
something like that.
very good. Very good. So basically, spectroscopy is a technique where we study what? The interaction. Okay. Basically, spectroscopy is the study of interaction of electromagnetic. Please do not write all the short forms that I'm giving here. It's for convenience. I'm writing like this. This is electromagnetic. So interaction of electromagnetic radiation. Okay, electromagnetic radiation with matter. So the study of interaction of electromagnetic radiation with the matter is termed as spectroscopy. So these uh, terms like infrared, ultraviolet visible, nuclear magnetic, all these are kind of coming under the category of electromagnetic radiations. And that is why for all this, we are using these terminologies called spectroscopy. Okay, but in mass, actually, we are using a term called spectrometry. And the reason why that is that because here we are not using any kind of not using not using any kind of electromagnetic radiation, but rather here we use a beam of electrons for the purpose. Okay, I'm not discussing you the detail. We basically use electrons to ionize molecules to determine the molecular mass. So basically, we are not using electromagnetic radiations here in the mass spectrometry. That's why we do not use the term mass spectroscopy, but rather just simply mass spectrometry whenever we talk about mass. So never use mass and spectroscopy together, because mass is not a spectroscopy, but rather it's a spectrometry, which doesn't involve any electromagnetic radiation. So keep that thing in your mind. Okay. So all these techniques that we are using here all involves the use of interaction of electromagnetic radiations with the matter. Okay, so what you mean by electromagnetic radiation? So electromagnetic radiation, as you know, composed of different kinds of regions in the electromagnetic spectrum. Okay, so you have high energy cosmic rays to very low energy radio frequency rays. Okay, so can you just talk about these? How does this particular, where do you find this particular rays, that is cosmic rays? Just quickly tell me these things you know about, right? Where have you heard? From where do you see this cosmic rays?
സ്പേസിലാണോ?
Yeah, because basically it's in the sun releases a lot of cosmic rays. Sun's radiation consists of cosmic rays. And what about gamma rays? Gamma rays നമ്മൾ എവിടെയാ എങ്ങനെ കൂടുതൽ ജനറേറ്റ് ആവുന്നത്? They are more produced by radioactive elements. So radioactive elements are the one, when they disintegrate, often releases these high energy gamma rays. And we know that these high energy gamma rays are uh, so high energy that if it comes in contact with any biological tissue, it can harm that particular tissue. Okay. Then comes another high energy species, which is electromagnetic radiation called X-ray. This particular radiation, though high in energy, if applied in small concentrations, doesn't cause any harm. And this is the particular technique that we use for all the medical examination of the bone structure in a human body. Okay, so that is one important thing. So ultraviolet and visible. Visible is the part that we actually are able to see with our own natural eyes. And these ultraviolet rays, again, emitted from the sun. Okay, and on constant exposure to ultraviolet rays, we might develop certain type of skin cancers. Okay, otherwise small exposures doesn't bring that, but constant exposure over a repeated period of time can cause skin cancer. Okay, so ultraviolet rays usually are not able to reach to us because of the blanket covering of the ozone. Okay, and this two electromagnetic radiations is that particular region we use in the spectroscopy dealing with the UV visible spectroscopy. So this part of the region is what we use for that spectroscopic purpose. Okay. Now coming to the infrared spectroscopy, this is kind of low energy spectroscopy. Here, basically infrared, as you know, it is basically causing the heating of the molecule. So it provides bit heating effect on the any surface, right? The heating that is done by the like the thing that keeps Earth warm is because of the infrared rays that are able to reach to the Earth. So that keeps the Earth warm. Okay. Now you have studied these particular regions of spectroscopy. Could you just enlighten me about what you know about these particular electromagnetic radiations and their interaction with matter? What do you know about it? Can you share with me? Like, you have studied the molecular spectroscopy in the physical chemistry. So from that, could you just let me know what you know about these electromagnetic spectrums. So, Pavitra, are you present today?
Yes, sir.
Okay. So, you have studied in physical chemistry molecular spectroscopy, right?
Yes, yes.
Okay. So from that, what you have learned about infrared, microwave, or radio wave?
ഇൻഫ്രാറെഡ് റേഡിയേഷൻ വരുമ്പോഴത്തേക്കും അവിടെ നമ്മൾ വൈബ്രേഷൻ സ്പെക്ട്രോസ്കോപ്പി എന്നാ പറയുന്നത്. അതായത് മോളിക്യൂളിന്റെ വൈബ്രേഷൻ നോക്കിയിട്ട്, അതായത്
Okay.
ഇപ്പം ഒരു ആറ്റത്തെ ഞാൻ എടുത്തു കഴിഞ്ഞാല് ആ ആറ്റത്തിന് ഇലക്ട്രോണിക് സ്റ്റേറ്റ്സ് ഉണ്ട്, അതിന്റെ ഉള്ളിലായിട്ട്, അതായത് ഇലക്ട്രോണിക് എനർജി ലെവൽസ് ഉണ്ട്, അതിന്റെ ഉള്ളിലായിട്ട് വൈബ്രേഷൻ ഉണ്ട്, അതിന്റെ ഉള്ളിലായിട്ട് റൊട്ടേഷനുണ്ട്. അപ്പൊ അതിന്റെ തമ്മിലുള്ള ഇന്ററാക്ഷൻ വഴി നമുക്ക് ഇതിനെ റൊട്ടേഷൻ ഇന്ത്യയില് മൈക്രോവേവ് സ്പെക്ട്രോസ്കോപ്പി വെച്ചിട്ടാണ് നമ്മൾ നോക്കാറ്. അത് കഴിഞ്ഞ് ഇൻഫ്രാറെഡ് വരുമ്പോഴത്തേക്കും വൈബ്രേഷൻ, അതായത് ഒരു മാറ്ററിലേക്ക് ഒരു ആറ്റം വന്നു കഴിഞ്ഞാൽ അത് തമ്മിലുള്ള ഇന്ററാക്ഷൻസ്, അപ്പൊ ഏതൊരു ട്രാൻസിഷൻസ് ആണ് ഇത് തമ്മിൽ ഇന്ററാക്ട് ചെയ്യുന്നതെന്ന് വെച്ചിട്ട് ബേസിക്കലായിട്ട് നോക്കുന്നത്.
So infrared, when it interacts with matter, what it causes to the matter? Like when I talk about organic molecule, any organic molecule, when the infrared is made to incident upon the organic molecule, what it causes it to happen?
ഇൻഫ്രാറെഡ് ആക്ച്വലി അത് മാറ്ററിലേക്ക് വന്നു കഴിഞ്ഞാൽ അത് തമ്മിലൊരു ബേസിക്കലി നമ്മൾ സ്പെക്ട്രോസ്കോപ്പി എന്ന് പറയുമ്പോൾ മാറ്ററും അതായത് ആ ഇലക്ട്രോ മാഗ്നറ്റിക് റേഡിയേഷൻ തമ്മിലുള്ള ഇന്ററാക്ഷൻ. അപ്പം ഇൻഫ്രാറെഡ് എന്ന് പറയുമ്പോൾ ആ ഒരു റീജിയൻ വരുമ്പോഴത്തേക്ക് അവിടെ വൈബ്രേഷൻസ് ആയിരിക്കും പ്രധാനമായിട്ടും പ്രൊഡ്യൂസ് ചെയ്യുന്നത്. അപ്പൊ ആ വൈബ്രേഷൻസിന്റെ ഇന്ററാക്ഷൻസ് വെച്ചിട്ട് ഒരു ഇലക്ട്രോൺ ഏത് വൈബ്രേഷൻ ട്രാൻസിഷൻ ആണെന്ന് വെച്ചിട്ട് കണ്ടുപിടിക്കും.
Yeah.
Structurally.
Yeah, pretty fine. Because here what happens is that infrared, when it, as rightly said by Pavitra, infrared, when it reacts with the matter, it causes the molecule to undergo vibration. So when the infrared frequency matches exactly with the type of vibration that particular molecule happens, it will absorb that particular frequency of the infrared region, and thereby we get a peak in that particular region. So if you have a simple diatomic molecule like HCl, so HCl vibrating at a usually have a bond strength, and you know that the molecule is not stable like a line, and രണ്ട് ത്രെഡിനെ കണക്ട് ചെയ്ത് എച്ചും സിഎലിനെ അറ്റാച്ച് അങ്ങനല്ല യൂഷ്വലി ഈ ബോണ്ട്സ് ഇരിക്കുന്നത്. There is always a constant stretching happening, or there is a equilibrium vibrations that is happening in this diatomic molecule. So they have a particular bond strength or a bond frequency with which these molecules are usually undergoing a stretching motion. Okay, so when the infrared rays you incident upon this particular HCl molecule, what happens is that one of the frequency of the infrared will match exactly with the frequency with which this diatomic molecule is undergoing these stretching vibrations. So when that frequency matches with this particular thing, at that time it will absorb that particular frequency of the infrared region. So it will cause a peak in the spectrum of the infrared. Okay, so that is how we come to know what all types of functional groups are present, because every functional group will have different frequency at which they will undergo the not only stretching, there are other kinds of vibration like bending vibrations also, and bending also we have a lot of different types of vibration, which I'll be introducing you next class. Okay, so that interaction leads to the various peaks in the infrared spectrum. Okay, so when microwave, so that is about the infrared spectroscopy. Now let me come back to so Pavitra, can you continue? Like microwave, when it interacts with electromagnetic microwave, when it interacts with the molecule, what it causes?
മൈക്രോവേവിന്റെ കേസിലാണെങ്കിൽ ഇപ്പൊ ഫോട്ടോൺ അബ്സോർബ് ചെയ്താൽ റൊട്ടേഷൻസ്, അതായത് ഇപ്പൊ ഇലക്ട്രോണിന്റെ റൊട്ടേഷൻ വെച്ചിട്ട് അത് മൈക്രോവേവ് എന്ന് പറഞ്ഞാൽ റൊട്ടേഷൻ സ്പെക്ട്രോസ്കോപ്പി. അപ്പൊ ഒരു ഫോട്ടോൺ അബ്സോർബ് ചെയ്താൽ അത് എത്രമാത്രം സ്പെക്ട്രം കാണാം. അപ്പൊ എത്രമാത്രം അബ്സോർബ് ചെയ്തെന്ന് മനസ്സിലാക്കി.
You don't say about like photons. Okay, photons is in general used for a visible light. Okay, so just say microwave,
ഇലക്ട്രോൺസ്.
microwave electromagnetic radiation. When it is incident upon the molecule, it will cause the molecule to undergo rotation. Okay, so you might have learned about symmetric top molecule, um, asymmetric top molecule. Different types of molecule നിങ്ങൾ പഠിച്ചില്ലേ rotational spectroscopy. Okay, so different spectral molecule undergo different type of rotational motion depending upon their symmetry. Okay, some of them are symmetric, some of they are not symmetric. So accordingly, the interaction of this microwave lead to a rotational motion in the molecule, and that is what is causing us to determine the spectroscopy using microwave. Basically, we do not study in general in organic chemistry. Why? Because it doesn't lead to any particular determination of structure. But microwave in organic chemistry we usually use to carry out reactions, because the rotational motion of the reactions can help to make certain reactions happen in a more faster rate. So basically, for that purpose we use in organic chemistry microwave. Microwave is not exactly used for structure elucidation of the organic molecule, but application part of microwave, if you ask me, it is used in radars. Okay, radars in the airports. Okay, where those radars are used actually to determine the distance of that aircraft from the airport. Okay, angane our radars we use these microwave. Otherwise, microwave is used for your kitchen appliances. So basically, rotational motion of the molecule is what causes the molecules to heat up. So നിങ്ങൾ വിചാരിക്കും ചില സമയത്ത് പാത്രം ഹീറ്റ് ആവത്തില്ല, പക്ഷെ കണ്ടന്റ് ഹീറ്റ് ആവുന്നു. That is because the patram is made up of the molecules which are not interacting with the microwave. Okay, it doesn't undergo, because certain symmetry doesn't interact with the microwave, because always if the microwave has to interact with a molecule, there should be a dipole interaction with the microwave. So if your molecule is a symmetric top molecule like methane molecule, okay, methane molecule is will not have any kind of dipole moment. So it's a symmetric top molecule. So the symmetric top molecules therefore will not interact with the microwave. Okay, so anganathe molecule vechu ningade paatram undaki kayinal adu heat up avutilla, because it will not interact with the microwave. But your content in the food, since it contains water molecules, okay, നിങ്ങളുടെ ഫുഡിന്റെ അകത്ത് വാട്ടർ മോളിക്യൂൾ ഉണ്ടെങ്കിൽ ഏത് കൈൻഡ് ഓഫ് നിങ്ങൾ ഫുഡ് ഉപയോഗിച്ചാലും അതിൻ്റെ അകത്ത് എപ്പോഴും വാട്ടർ മോളിക്യൂൾ വുഡ് ബി പ്രസന്റ്. സോ ദോസ് വാട്ടർ മോളിക്യൂൾസ് can very easily undergo interaction with the microwave, because we know that water molecule is angular in shape, so it has a set dipole moment. So obviously that will interact with the microwave, and that is why you have that commodity being heated without affecting the overall temperature of the container which contains that particular substance. Okay, so that is the technique that is used in the microwave for doing all the cooking works. Okay, so in organic chemistry we do not use microwave for structure elucidation. We only use it for carrying out certain organic chemistry reactions, because rotational rotation of the molecule helps in making rotation of the molecule helps us to make these reactions to happen more conveniently. Okay, and then another part of the spectroscopy is your radio wave spectroscopy, and this radio wave spectroscopy is what we use in the NMR spectrum. Okay, NMR, or in medical side we use in MRI scan. Okay, ningal eppoഴും കേട്ടിട്ടുണ്ടായിരിക്കും. So that again uses this another form of this radio wave to scan the tissues in your body. Okay, so if you want to determine exactly the structure of the tissues present in your body, you will not use X-ray, but you will use MRI to scan them. Okay, so that is a basic understanding about the various regions of the spectrum and their applications to the corresponding spectroscopic technique. So in the next class, we will start our discussion with the infrared spectroscopy, and we will try to understand how that helps in determining of the structure of the compound. Okay, so with that, I would like to stop today's class. So let me take the attendance. Okay. Let me first stop this recording.